of matrix. It's not today. Today we'll talk about those properties of matrix. Okay. Here I want to focus on something is very important. If we have first one, okay, close this. Let's A be first of all it's square matrix. Okay, let's be this one is a square matrix. Okay, then the following statements are equivalent. What are those? A is invertible matrix. We talk about when A either all statements are either true or false. If square matrix should be invertible matrix, no. Expect that A equal not equal 0. It's very important. Another thing. This is not important. This is not important. This one, the equation Ax equals 0 has only the trivial solution. That's one solution. This is not important. The equation Ax equals 0, we spoke about those before, has at least one solution. And sure, this is because we talked about this before. Spam is not important. Okay, this is not important. Here you can ignore this one, this theorem if you want. It's not very important, but you can ignore this one if you want because there is nothing new in this one. Here, see this. This is a little bit important. That A and B are square matrices. So if A multiply B equal I, so A and B both are invertible. So we can say B equal A minus 1 or A equal B minus 2. We can say this one. Okay, what is else? Here we spoke about how we can find or solve invertible matrix based on this one. Okay, this is cancelled. This theorem is cancelled. This one is cancelled. Okay, now I want to see some important. Where is this? Nothing here. Nothing important. Nothing about this one. You can, in my view, you can ignore this chapter to check if it's important or not. Just this one if you want. You can focus on study this one. Otherwise, all of these are not important, so you can ignore this one. You can ignore this chapter if you want. It's not really important for this one. Now here also we have 2.4. This is just reading. I will give you information, but in exam it's not included in exam. This one is called partial matrix. What is this? Usually, if we have big matrix like this one, and we can divide this matrix to small matrix. Just this is our lecture today is just for not in exam, just for reading. So we can make like this small matrices, And after that, you can make operation in this one. So this is the idea for this. Here, part it's a way to divide the big matrix to be small matrix and deal with this matrix. But here we have a problem. Where is the problem? How can I divide? How can I make partition or block matrix? Here we are. So, for example, if I have this A, additional and scalar multiplication. Okay. For additional, we have a condition. That means size of A equals size of B. For example, I have this is A11, A12, A12, A21. So if I want to make plus, so A11 should equal B11. A12 should equal B12. So this is the division if you want to apply for partial matrix. For multiplication, it's a little bit hard. How is this one? Number of row, it should equal the number of column. So for example, this is A11. Here, what is the size? 2 multiply 3. So here should be 3 multiply 2. This like this to make this operation. So a little bit hard for partial matrix. So this is just explanation for you. We have a way to divide matrix to small matrices. This is small matrix can we use for reduce the size, but we have a condition and you have to know how to divide. For example, you can divide for some another kind of for multiply, and you have to take in your consideration that means number of row and number of column for this. This is about partial matrix that I talk about this one. So see here we have row and column. Inverse of partial matrix, we don't need this one. Again, you can skip this one. Let's go with this one. So just today reading those. We don't need an exam. Let's go. Factorization of matrix and equation. Again, this is not an exam, just reading today. Today, just reading is an equation that expresses A as a product of two or more matrices, whereas matrix multiplication involves syntax of data commutation of effect of two or more linear transformation. Okay, again, this is kind of, can cancel this one also if you want. So again, this is kind of cancelled. You can cancel this one. It's not important. It's common use. Else, because I want to finish this chapter. Here. Again, this is also cancelled, 2.6. Application of this one. No, it's not included. Excuse me. Who said that? No, it's not right. You have to focus on operation and inverse of matrix. Just clear. Hamdi, what's your name? H, what's your name? First name. H-A, what's your name? First name. Mustafa, what's your name? Hiba, this is not included in exam. Just this reading. I want to show you this one and when you can apply. Just so today is reading to understand all the concept. But this is not included in exam. You are not requested in exam for this one. Hiba, clear? Stick here for all. This is our lecture today. Is not included in exam, but so we can still learn all these topics in our we are talking about this one. If there is something, I will tell you during that class. The application of computer graphic in matrix. Okay, see here, for example, for computer engineering, you can use this one for vectors or for a graph. Where can I apply matrix? For example, the capital N here in figure determined by 8 points here. We can divide, for example, any letter to point and after that you can make x and y, and you can express this one as a matrix. So this is for you, for example, as a computer engineering, where I can use this matrix. For example, we have this letter as n letter. You can divide this one for each edge, 3, 4, 5, 6, 7, 8, and after that you can divide to, for example, point x and y. X, y. For example, for x we have 0, 0, 5, 0, 5, 6, 6, 5.5 based on the size x and y, and after that you can make d. And this idea we are using for example for this for mouse. For mouse, if we have like this screen, and we have, for example, this is x and this is y. So if my mouse is here, I can determine where is x, where is my y. Then I can know the mouse. Or if I want, I can focus just on the pointer, this one, to know where is x and y. Then I can make matrix for x and y. And this is what are doing, for example, for hacker. If they want to hack you, they are following this one, x and y, for your matrix, to know where is your pointer. This is for mouse. So again, see here we converted any movement for this mouse or like this to be x and y, and to be after that matrix. Then you can apply anything for you need for this matrix. Is it clear? Okay. Now, no. Who said no? AS, what's your name? AS Dawood, what's your first name? Can you repeat? Okay, we'll repeat. Listen to me. For mouse, for example, if I move like this, I am moving my mouse. Abdul Salam. See, for example, this is my mouse. I will start from this corner, uplift. Then I will divide screen to x and y pixel. For example, this is my mouse. I can know where is my mouse based on this x and this y. For example, this x is here. I can make pair. For example, 2, here it is 4. So now my mouse at 2, 4. If this mouse moved to another place, here for example, I can know another one. For example, here 3, C4. Then you can convert this as a pair to matrix x and y. For example, this is x, here 2, 4, 3, 4, 5, 6, 7, 8, for example. So at each one, this is, for example, first place, second place, third place. So you can after that apply, for example, prediction or any operation that you want for this matrix based on what do you want from this matrix. You want, for example, to predict, for example, to know where is this one, to hack this one. For example, if I have a screen, I have another screen like this one. So if this mouse move here, my mouse move here. If my mouse come here, my mouse also will come here. So this is the technique they are using for hacker, especially for mouse. So mouse, they are using X and Y to predict where is it. Got the idea, Abdul Salam, or repeat? Is it clear or repeat, sirs? Okay. So this is the technique that are using hacker to hack the websites. Okay. Now let's see something about what is it? Here. See, for example, here I want to show something, not details. See, for example, here they are using for projection, for expanding. For example, I have this one, I can expand. For example, I have this shape. Then I will expand this one. for example, for oscilloscope or microscope, then I can increase this area to be like this area based on size. How can I, for example, he multiply with 3. So this 1 by 1 will be 3 by 3. So I have small pieces here, small thing here, small thing here. I have another one here, but enlarge. So this is 3 also. For example, let's say this is A, this is B. See B equal 3, for example, multiply A. So in this case, you can enlarge the size of things that you are seeing in the microscope. Else,